In this video, we will learn to load llama models locally and create completions using our local model. We can use llama with llama-cpp-python, a Python binding for llama.cpp, which is a standalone C++ library for running advanced language models on the cloud or locally with hardware acceleration. It works with Python version 3.8 or higher and requires a compatible C++ compiler. We can install this library easily via pip. The library supports all the variants of Llama and other popular LLMs such as Mistral and Falcon. To load a locally stored model using llama-cpp, we need to import the Llama class. Then we instantiate the class with the model path pointing to the file. Optionally, we can load the model to GPU with ngPU layers set to -1. Running model completions are typically faster on GPU. If we want to get the same responses to the same inputs every time, we can set a seed to ensure results are reproducible. We can also set nContext to change the size of the context window. However, we have to be careful to set this value at or below the maximum context size of the model we have loaded. We can also load models directly from Hugging Face, where we can find other variants of Llama trained and modified by the ML community. We first need to install Hugging Face Hub as a dependency with pip. Then we can import the Llama class as usual, except this time, when we instantiate, we use the fromPretrained class method and pass in the repo ID, which identifies the repository where the models are stored from the Hugging Face website. We can also pass in the file name to load a specific version of the model. We run completions by calling our class with a string prompt with a small max tokens and some stop tokens. We can set the temperature. Higher values make the generation more random. Increasing repeat penalty makes the model produce new words by reducing probabilities of words that it has already produced. Both values are lower bounded at 0 and can typically go up to about 1.5. Temperature has a default of 0.8 and repetition penalty has a default of 1.1. We can also explicitly use the createCompletion method with the same inputs to generate a completion. Chat completion makes the LLM more conversational. We start by calling createChatCompletion and passing a list of messages, which contains a sequence of the conversation so far. Each element in this list has a role, user, or system, or assistant. The content is the message being passed. The first message is the system instruction, defining a system who speaks only Shakespearean. The second message is the user asking a question. We can retrieve the completion the model produced with this code, which shows this output. Very Shakespearean.